As we wait for folks to join in here for the Ohio River discussion series, if you could please add your name to the chat and the organization that you're with for others to see who's on the call today. Thank you. So if you're just joining us for the Ohio River discussion series, you can add your name to the chat and your organization, and we're going to go ahead and get started. Thank you.
All right, everybody. Welcome to the March edition of the Ohio River discussion series. This month's webinar is going to focus on student voices, focusing on Muskingum Watershed Conservancy District student research. So welcome, everybody, and welcome to our speakers. We are excited to have with us today, advance my slides here, sorry, Isabella Byrne, Michael Bourne, and Shiva Basnet. Before we get started with our speakers, I wanted to go through a few housekeeping items really quickly. If everyone's already put their name in the chat, that is excellent. If you haven't done that yet, go ahead and do that now. We also ask you right now to mute your microphone and disable your camera unless you're actively using them to present. We will hopefully have time to take questions at the end of this webinar, but feel free to submit questions in the chat throughout the webinar, and we will have folks monitoring them and we can answer them later. The discussion will be recorded and uploaded to ORBA's YouTube page. In the next few days, you can expect an email with a link, but you can also go directly to Orsenco's website and find the Ohio River discussion series link, and you can find the YouTube videos there. We'll be also sharing at the end of the webinar a QR code that you can also scan to access those. If you have ideas for future discussion topics, or if you're interested in speaking or helping with future sessions, please reach out to Jen Bowman. Jen Bowman's email is on the slide. She's also put that information, her email information, in the chat as well. So please keep in mind that this is the last webinar of our 2026 series. So we'll have a few months for folks to start getting creative and thinking of ideas. And if you have anything that comes to mind or spurs your interest, please reach out to Jen. So as I may have mentioned before, my name is Heather Mayfield. I am an ORBA board member and am also vice chair of the Foundation for Ohio River Education, or FOR. And FOR is a nonprofit organization whose mission is getting people engaged in protecting the Ohio River and their watersheds through hands-on programs. And FOR was originally established by the Ohio River Valley Water Sanitation Commission, or Orsenko. I think a lot of folks on this call know who Orsenko is, but for those who don't, Orsenko is an interstate commission that was developed in 1948 to control and abate pollution throughout the Ohio River watershed. So the commission is made up of 8 states in the federal government, and our member states include Ohio River Basin states such as Illinois, Indiana, Kentucky, Ohio, Pennsylvania, and West Virginia. So Orsenko works collaboratively with our basin states and the federal government to ensure that the Ohio River is clean, usable, and sustainable for people and wildlife. And the way that Orsenko does that is through a variety of different programs designed to monitor, improve water quality in the Ohio River and its tributaries. And these programs include water quality monitoring programs to protect Ohio River uses. These uses include drinking water, industrial water supplies, recreational uses, and supporting a healthy aquatic habitat. We have biological survey programs that assess fish and macroinvertebrate populations up and down the entire length of the Ohio River, as well as assessing levels of contaminants in fish. We have emergency and spill response coordination. And finally, last but not least, and very importantly, communication and outreach programs. And these programs are designed to improve public perception of Ohio River water quality and promote its protection and preservation. So Orsenko is also a fiscal sponsor of the Ohio River Basin Alliance and one of the main sponsors of this webinar. And we thank our Orsenko staff for also providing technical support for this webinar as well. So Orsenko operates, again, it's an interstate commission. So each state appoints 3 commissioners to the commission. The federal government does as well. Orsenko receives its funding through our member states and through the U.S. Environmental Protection Agency. The work that is basin-wide and river-wide is carried out through a very small and mighty staff of 22 internal employees. And we work collaboratively with a vast network of numerous interagency and stakeholder commission advisory committees, as well as agencies such as the U.S. Army Corps of Engineers, USGS. We work with drinking water utilities, wastewater utilities, and several watershed organizations. And many of those organizations may be represented today as participants on the call. So we thank you for your collaboration and we thank you for joining us. And now I'm going to hand it over to Jen to introduce our speakers.
Thank you, Heather. Well, Isabella, you can go ahead and pull up your slides while I'm doing your introduction here. So I have the pleasure of introducing Isabella Byrne. She is a second-year master's student here at Ohio University's Voinovich School, and I've had the pleasure of working with Isabella on various projects while she's been a student here. So she's Master of Science Environmental Studies student, and her research has been focused on microplastic concentrations in the Tappan Lake Reservoir, and her title is The Concentrations of Microplastics Through Surface Water of Tappan Lake Reservoir. So Isabella, if you want to go ahead and share your slides and put it in the slide mode, presentation mode here.
Yeah, absolutely. All right, and everyone can see this?
Yes, thank you.
Perfect. Hi, my name is Isabella. I'm a second-year MSCS graduate student in the Voinovich School at Ohio University, and my thesis and research is focused on the occurrence of microplastics throughout the surface water of Tappan Lake. So these are just my quick acknowledgments, all the people that made my research possible and that I wouldn't have been able to do it without. So for my introduction, just a little bit of background on microplastics. So what exactly are microplastics? These are just some photos that I found in my samples. They can range from 5 millimeters to 1 nanometer, and there's 2 different types. So there's primary and secondary. Primary are microplastics that are originally made small, whereas secondary are microplastics that break off from larger pieces of plastic. They can be defined by their shape, color, size, and also their polymer type. And then there's 4 main types, which are beads, pellets, fragments, and fibers. Microplastics can come from an array of different areas. So primary microplastics, also known as PMPs, can come from plastic pellets from industrial production, or also plastic fibers that are originally created small for clothing. They can also come from things like self-care products and so on. Secondary microplastics, also known as SMPs, come from things like broken down bottles, plastic bags, fishing nets, textiles, tires, and any other larger piece of plastic. The microfibers for primary versus secondary can get a little tricky. So, primary fibers are ones that were originally made small. They become secondary when they break off from pieces of clothing like this sweater. Microfibers are by far the most predominant fibers that are found. Microplastics in freshwater environments also most commonly come from improperly managed waste, industrial materials, personal care items, and synthetic textiles. Airborne particles also contribute significantly to where these microplastics are coming from in freshwater environments. So microplastics in freshwater environments, they're easily transported because they're so small and they have such a high environmental resistance. They break down and spread immensely in aquatic environments because of factors like UV radiation, heat, wind, waves, ripples, and flocks. Flocks are areas that they latch onto and move around in the water. They can be introduced from an array of different areas, such as direct access to the body of water from tributaries. They can enter the lake from industrial waste runoff, surface runoff, erosion, wind, tourism, fishing, and a whole other array of factors. Atmospheric fallout also acts as an origin of microplastics, so they're airborne, but they can also come from snow and rain. Environmental factors like rainfall, droughts, storms, flooding, and so on also contribute to the origins of them. So concentrations of microplastics in freshwater environments also come from multiple different areas. Geographical location, wind, currents, weather, and so on all can influence their concentration. And human population, density area, and their proximity to urban development also contribute significantly. The relationship between the development of the watershed and the land use contributes as well. So my questions for my research were, what is the abundance of MPs throughout the surface water of Tappan Lake? Is there a relationship between the site and the quantities found? Does the sampling date have any effect on the quantity of microplastics found? And are PMPs or SMPs more abundant throughout the surface water? So Tappan Lake Reservoir is located in Harrison County. It's a part of the Muskingum Watershed Conservancy District. It has 2,350 acres of surface water, but then 5,000 acres of parkland that provides a multitude of recreational purposes. There's a U.S. route that runs along the lake, and it also serves as a drinking water source for a local town. Where that blue dot is where Tappan Lake is on a map of Ohio. It's more eastern Ohio. So Tappan Lake's land use, it covers 45,220 acres of land, and it has an array of different land usages. The biggest one is forested, but it also has some developed area, but overall, I would say Tappan Lake is mostly rural. Tappan Lake watershed consists of 3 different subwatersheds, which are Clear Fork, Standing Stone Fork, and Upper Little Stillwater Creek. There's also a dam located across Little Stillwater Creek where the water flows out of Tappan Lake. All the samples for the purpose of this study were taken in the Upper Little Stillwater Creek watershed area, which is on this map, that purple site. Water flows into Tappan Lake from 7 different named tributaries, which are Beaver Dam Run, Willis Run, Eddington Run, Leaper Run, Lower Beaver Dam Run, Standing Stone Fork, and Clear Fork. And Tappan Lake also outflows into Little Stillwater Creek, which is where the dam is. And this is just a map of where those tributaries are. So my sample collection sites were chosen based on location, purpose, and their accessibility to get to. There were 6 sites chosen, which 3 were on the shore and 3 were open water. Open water sites were 30-minute transects to be able to effectively capture a majority of Tappan Lake's surface water. Shore samples were chosen for their inflow, recreational use, and their outflow. Every site was replicated twice on every sampling day, and I also used a blink to factor in airborne particles. They were collected in September, October, and November of 2025. This is just a map of where those sites are. So sites TLT 1, 2, and 3 were the open water transect samples. Site TLS 01 was a shore sample chosen specifically for its inflow into the lake. Site TLS 2 was a shore sample chosen for the recreational use. That site is located right where the marina is. And site TLS 3 was a shore sample that was chosen for its outflow near the dam. And then the order of sampling that occurred on every day was the same order. So my materials for sample collection, I used a 150 micron plankton net with a 1 foot diameter. I chose this size to ensure that the net wouldn't get clogged and also would still effectively capture particles that were present. I used a telescoping pole, a 125 micron stainless steel sieve, a metal bowl, a DI water, and a squirt bottle, and then a pint-sized mason jar for sample collection. For sample processing, I use glass flasks and beakers, iron sulfate, concentrated sulfuric acid, DI water, and glass stir bars. And for sample analysis, I used a 3-place vacuum filter, which is shown right here, a 10 micron PC membrane filter papers, glass petri dishes, dissecting microscope, forceps or tweezers, and needles. And to ensure high quality data, I use procedural blanks during all of the processing and filtering and sampling because airborne particles are the most common source of contamination. And I took precautions such as cotton lab coats or cotton clothing, non-plastic containers if I could avoid it, non-plastic tools. I minimized airborne contamination by ensuring the samples were always covered, and I used strictly DI water. So my methods for sample collection, 36 samples were taken from the surface water in total, and I had 3 blanks for every field day to add an additional 3 blanks to make 39 samples. For the shore samples, the 150 micron plankton net was pulled for 5 meters from the boat, and the average distance for the transect samples varied slightly, but they were all quite longer than the shore samples, so we normalized that by volume. For the open water samples, the 150 micron plankton net was tied to the telescoping pole and was then pulled along the surface water for a duration of 30 minutes at idle speed. After every sample, the net was rinsed with DI water 3 times, and then the cod end was removed. The cod end was rinsed with DI water into a metal bowl, and I repeated this step as many times as necessary because it did take more than just 3. Once the cotton was completely rinsed, the remnants were then put into a metal bowl and filtered through the 125 sieve to remove excess water, just to limit the water that was getting transported back to the lab. The contents in the sieve were then put into a clean mason jar and they were labeled and stored in a cooler until transport to the lab, and samples were then stored in a freezer until processing. So during sample processing, 3 blanks were used. Samples were put into a clean 1,000 milliliter volumetric flask and beakers. An iron catalyst solution was used to oxidize any of the organic matter that was in the samples. So 15 grams of iron sulfate was added to the 1,000 milliliter containers, which were already containing the samples in them, and then DI water was added until the 1,000 milliliter line. Stir bars were then used to stir the mixture until the iron sulfate was completely dissolved, and that's when the 6 milliliters of concentrated sulfuric acid was added. After this, the sample was covered and stored for 24 hours. I used time rather than another common method of heat to dissolve the organic matter because heat can sometimes damage microplastic particles. My methods for sample analysis, I used an additional 3 blanks during filtration. Samples were filtered through the 3-place vacuum filter onto the 10 micron PC membrane filter. The papers were then put into a glass petri dish and they were stored in the freezer until further analysis. The papers were also divided into 4 different sections to ensure that no particles were accidentally overlooked. And then they were analyzed with a dissecting microscope a minimum of 3 times. And I also conducted the hot needle test, which is you heat up the tip of a needle and you poke suspected particles, and however they react confirms whether they're microplastics or organic matter. Again, methods for sample analysis. So each sample was evaluated twice, a minimum of 3 times both times. The first set of evaluation, the particles were analyzed without the hot needle test to not damage any particles. Some organic matter still remained in my samples, so I consulted with a PhD student who's also studying microplastics just to gain an additional opinion on what his thoughts were. The second set of evaluations did use the hot needle test this time to confirm whether or not it was organic matter that remained or microplastic particles. The particles that had characteristics of microplastics, like color or shape, were the ones that were counted, as well as particles that 100% passed the hot needle test. And then in order to calculate the surface water that went through my plankton net, I just did area multiplied per distance of each site. Okay, so this shows the microplastic occurrence and types by sample in September. So these are the total particles that were found for each site, as well as the types that were found. And this breaks down the particles per cubic meter because we normalized by volume since there was a great disparity between the distance of these samples. So that's what this shows. In these pie charts, the one on the left shows what the particles were, what types they were, and the most predominant was the microfibers at 83%. And the one on the right shows the color of all the particles found, with the most predominant being black. So the environmental factors in September was the average wind speed was 4 miles per hour. It wasn't very windy. The lake state was very, very calm. The air temperature was roughly 26 degrees Celsius, and the water temperature was also 26 degrees Celsius. There was no precipitation that was happening during sampling, and as I watched weather data leading up to the sampling date, there was no precipitation in the 7 days before. So for September sampling, site TLS1, which was the inflow site, did have the highest concentration at 17.14 particles per cubic meter. Shore samples had 30 particles, whereas open water only had 29 particles, and 59 were found in total. My field blank did have a fiber present. It was a red microfiber, and my processing blank also had a black microfiber present. This shows the microplastic occurrence and type for October. So this also just breaks down every single site and how many were found, as well as what type was found. This breaks it down by cubic meter, just to normalize it. And then for the month of October, I did not make a pie chart for the type because fibers dominated it so highly at 96.3%, and films made up 3.7, but no other particles were found for this sampling date. Again, black was the most common color found for the fibers. The environmental factors for October 6th, so it was pretty similar to the September samples. The wind was 5 miles per hour on average. The lake state was again very calm. The air temperature was about 25 degrees Celsius, and the water temperature was about 22.8 degrees Celsius. And there was no precipitation again during sampling, and the weather data also showed no precipitation leading up to the sampling date for the 7 days before. The inflow site of TLS1 was again the highest at 17.15 particles per cubic meter, and shore samples and open water samples both had an equal amount at 27 particles found. There were 54 particles found in total, and the field blank did have one blue microfiber present, but there were no other particles in my other blanks. This shows the microplastic occurrence and type by sample in November specifically. And again, this just breaks it down by total and type. This explains it by cubic meter. And then these pie charts also break down the most common types, which fiber again dominated at 90%, and black was again the most common color found. The environmental factors for November were much different than the first two sampling dates. The average wind was 13 miles per hour, and the lake state was very, very choppy and rough. The air temperature was about 9 degrees Celsius, and the water temperature was about 13 degrees Celsius. There was precipitation while we were sampling, but the weather data did show no precipitation for the 7 days leading up to it. TLS1, again, had the highest average concentration at 20 particles per cubic meter. The shore samples had 31 particles present, and open water samples had 38 particles present this time. There were 70 particles total for this sample, and the field blank had 2 particles present, one red and one black microfiber. So this breaks it down by the average per cubic meter. So this is shore samples versus transect samples. Shore samples had significantly higher amounts of microplastics per cubic meter than transect samples did. So this suggests that the microplastic concentrations are higher where the water is flowing into the lake, also where there's recreational use and where water is flowing out of the lake. Site TLS1 had the highest average microplastic concentration for every single sampling date, suggesting the inflow to the body of water was a major origin of microplastics. Direct access to the body of water flowing in from tributaries, discharge, currents, wind, land use, and also human population density could have contributed to the concentrations that were found. Atmospheric fallout and airborne particles also were probably an origin, since every single field blank did have particles present. This shows the occurrence across sampling dates overall, and there was no significant difference across sampling dates during this time. This shows the difference between primary and secondary microplastics throughout Tappan Lake. Secondary microplastics were by far more predominant than primary, and there was a very significant difference in those. The microplastic type throughout the surface water of Tappan Lake was predominantly fibers. This was all the samples combined to see what was most dominant, and it was fibers. The color throughout the surface water of Tappan Lake also was predominantly black. These are again all the samples put together. Okay, so some of my limitations, my sample number, if I were to do this study again, I would have more samples. I would probably go from a longer length of months as well. There was a big disparity in the distance of the shore versus transects, but we did normalize this by volume. The direct shore access, for some of our sites that we picked, couldn't access the land, so we had to pull the boat up onto the shore, which caused some trouble sometimes. The changing water levels, on October, the water was lower than the other two sampling dates, so we had a hard time accessing the exact same points that we did the other two sites. The chemical oxidation, the organic matter didn't dissolve quite as well as I thought it would. It did dissolve, but just not nearly quite as clear as I was expecting, so that was a limitation. And then polymer identification. I was able to identify the plastics down to color and shape, but I didn't have the resources or the time to identify them down to what their actual chemical makeup was. So my conclusion was that I found a total of 183 particles throughout the surface water of Tappan Lake. There was a significant difference in the amount of particles present in shore samples compared to the open water samples when they were normalized by cubic meter. The sampling date did not significantly affect the quantity of particles found, though, and there was a significant difference in the amount of secondary microplastics found throughout the surface water compared to the primary microplastics found. It's just, sorry. Okay. Thank you.
Thank you, Isabella. Let's hold our questions to the end just so we can get through our other two presentations. If you do have questions, please put them in the chat and Isabella could answer them that way, or we will get back to them at the end. Thank you for your presentation. It was very informative. I'd like to introduce our next speaker, Michael Bourne. Michael, you want to pull up your slides while I'm reading your bio here. Michael is a PhD candidate in applied geology at Kent State University. He's using drones and satellite remote sensing to monitor harmful algal blooms and invasive aquatic vegetation in the Muskingum watershed. Thank you, Michael.
Can you all see that?
It's in slide mode. It's in the slides mode instead of the slideshow mode.
Oh, there we go.
All right. Thanks.
So today I'm going to be talking about looking at harmful algal blooms and invasive submerged aquatic vegetation at Pleasant Hill Lake using multi-platform remote sensing. As mentioned, I'm a PhD candidate. I'm in my third year. So this is a lot of preliminary data and more is to come. So this is in part with the help of Kent State University and funding through Muskingum Watershed Conservancy District for this preliminary data. And so Pleasant Hill Lake is located within the Muskingum watershed. So the map on the right kind of shows where exactly it is. It was created by the U.S. Army Corps of Engineers for flood control back in 1936. It has a pretty sizable drainage basin with a residence time of roughly 24 days. And the reason why we're looking at Pleasant Hill Lake is because it has a lot of inputs. And so the bottom picture there shows a number of different inputs. The primary one is the Clear Fork of the Mohican, which has a lot of agricultural influence, and the Switzer Creek, which also has a lot of agricultural influence. But you can also see a number of farm fields that kind of flow directly into Pleasant Hill Lake, along with a golf course, an RV park, and there's some residential stuff. So we're looking at some harmful algal blooms. It's widely used for recreational purposes. So the safety of the lake becomes super important to look at. And so overall research objectives, which I will touch on some of these here. I mean, it's quite a bit. Track seasonal changes for phytoplankton and nutrient drivers to understand the bloom dynamics. So to see how these algal blooms are changing throughout the season and what nutrients are driving it and where those nutrients are actually coming from. That way, folks might be able to use this data and to build some management practices. Another issue with the lake is that they have some invasive species, particularly Aeneas minor. And so The idea here is to try to differentiate that particular species from other species in the lake. And so for this particular study, I'm going to use lakes closer to Kent State, Sandy and Brady Lake as proxy lakes, and then apply that model to Pleasant Hill Lake to see what we can get out of it. In order to do some of the differentiation and look at the phytoplankton, I'm going to take a multi-platform remote sensing approach and looking at it at different levels. We have a drone, which I'll talk about here in a minute, that has a very fine resolution. We're going to use Sentinel-2, which is about 10 meter, and then a hyperspectral sensor NMAP, which has a 30 meter, or we might use emit. But so to use multispectral and hyperspectral remote sensing to look at these environmental characteristics. And then hopefully this creates a model that Muskingum can use to help manage the lake. And so our drone is an Event 38 mapping drone. It has an Eagle NXT MicaSense Red Edge P dual multispectral camera. And so that consists of 10 spectral bands in the visible spectrum range to near infrared, which is roughly comparable to the satellites that for commercially available satellite data, such as Sentinel-2 and Landsat 8 and 9, but the drone lacks some of the thermal and the shortwave infrared stuff. And we have quite a bit spatial resolution going on, roughly 7 centimeters. And so on the right-hand side, there's a drone image that we were able to capture. And that's Pleasant Hill Lake on the left-hand side. But I've blown up. What else we're doing is we're putting down some plates to be able to oh, I just blanked. So that we could use the data for atmospheric correction of the data itself. So that's why there's a few different colors. And so what has been completed, so there's been preliminary data in August of 24, and then I did some spatial collection data last year, August through October. And so the methods that I used and will continue to use is using the drone. So every time we go out, we take drone data. We use a spectroradiometer to measure spectral reflectance of the water itself when we're out on a boat. We take some other parameters using a FONREST, such as temperature, DO, pH. Use a fluoroprobe to measure the algal type and the amount that's actually within the water column. And so we take measurement throughout the water column itself. Variety of water samples. So some of those samples and some of the data I'm going to show you here come from BSA Environmental, which is a place very close by. And they do a really high quality analysis looking at the type of algae that's there, the amount that's within that sample itself. And then in order for nutrient analysis, things like the ICP and the scalar, we take filtered water samples from both the surface and the bottom that will be used for various neutral analysis. So some preliminary data that we did here this past summer. So the sample collection included August, September, and October. And so every one of these pins were a site that we collected data from. And then the purple represents where we flew in the drone. And so you can see there a number of different nutrient analysis that were done. On the right-hand side, I'm just highlighting phosphorus, since that's one of the primary drivers of algal blooms themselves. And so the top represents the surface collection, and you have a pretty decent amount showing kind of coming in from the clear fork that's there, and then you have some that's kind of hanging out, maybe coming from these farm fields along the southern edge. At the bottom, you have phosphorus, which was taken from the bottom. And so the color represents the depth, right? And so white is up near the surface, or sorry, a shallower depth, and then blue is a deeper depth. And then we have overall concentrations that are there. And so we are seeing some phosphorus maybe coming up from the sediments themselves, kind of helping drive some of the algae. And so here's some of the BSA data that I like to highlight. And so two two species that I want to focus on are the diatoms, which are the brown, and then cyanobacteria, which is the blue. There are other things that have been found, such as the chlorophyta and the cryptophyta, but the dominant players in this lake are definitely the diatoms and the cyanobacteria. And so with these pie charts, you can see roughly the percentage of each. And so when we're a little bit further, these are also taken on different dates, so keep that in mind. But when we're a little bit further away, you're seeing a bit more diatoms. We're a little bit closer to the Clear Fork. We're seeing a bit more of the cyanobacteria that's within there. And that's because we have kind of two different things going on. We have the primary driver, the nutrients coming in, but the sediment down below, the underlying geology is actually sandstone. So the diatoms have plenty of fuel to kind of keep themselves going. And so with that, I'd like to highlight kind of three locations because these had the highest percentage of cyanobacteria within them. So if we break that apart, look at it a little bit more in detail, which of those cyanobacteria are potential toxin producers and which ones are just kind of other ones that are hanging out. And so with those, at each of those samples, we see a good percentage of those have the potential to produce harmful toxins, right? And so I did this in 24 and 25, and we're seeing very somewhat similar results, at least in the same area. Although in 24, some of those areas had much higher amounts of cyanobacteria in them. But again, the overall general consensus is, a majority of the cyanobacteria that we are finding is or can produce harmful toxins, which that's super important because here in this area, there's boat docks and people swim in this particular area. So public health is definitely a primary concern for this particular lake, right? And so what species do we find? And so I've divided them up into severe, moderate, and minor threats. And so severe threats are including microcystis, Dilophospirillum, Rapidopsis, and Aphanizomenon. And then I highlighted how many sites they were found at. And so the one that was found at the most was Rapidopsis. And so these particular severe threats can produce microcystin, which affect the liver and kidneys if ingested in large enough quantities. And they also can produce some neurotoxins and those particular things. We have some moderate threats, Anabanopsis and Pseudoanabana. And so those were found at 11 and 10 sites respectively. Both of those can also produce microcystis. And then we have some minor threats that are there. They can produce microcystins, but rarely does that happen, but it's still worth mentioning a couple of sites there. And so looking at analyzing some of the data from BSA and looking at the overall biovolume. So the Ohio EPA sets some bloom guidelines for the amount of biovolume that's acceptable. And so here we have a severe bloom. The biovolume is greater than 10 cubic millimeters per liter. Moderate is 1 to 10, and then minor is essentially under 1 cubic millimeter per liter. And so of the data that I received from BSA, kind of went through and plotted it out. And so on the right-hand side, we have or left-hand side, the total cyanobacteria biovolume, and then we have the 3 dates that I managed to get samples from. And then I have highlighted here where the moderate bloom starts, right, in the orange, and then where the severe bloom starts, okay? Further subdivided into the severe threats, the moderate threats, and the minor threats. So the ones that I talked about previously of the major players in some of these categories. And so each of the different sites have at least moderate concerns. Nothing was in the severe threat, although we have the Pleasant Hill number 19 up here towards the top, had a high amount of minor threats. So that's a bit of an outlier, but you have that with science. Number 33, which is kind of here near the mouth, that had a pretty high amount of the severe threats. So things like the microcystis and stuff that's to be aware of. Because if it gets out of hand, then a whole different set of problems can going to kind of occur as a result. And so proposed field campaign kind of continuing on since I'm only my third year. I'm going to take another summer and kind of continue this research is to continue to quantify those nutrient loadings, but do it throughout the entire season. So last season was more kind of snapshots and getting an idea of where things might be coming from, so that this year I could focus more on where those potential threats could be. And so at Pleasant Hill Lake, it's going to be primarily May, July, and August. So May to get a kind of a baseline, July to get a sense of when the algal blooms are going to be the most, and then August to see what's kind of sticking around throughout the season. That's going to be paired with water quality data and drone surveys, including the stuff being sent to BSA, ICP, scalar analysis, all those things that I mentioned previously, looking at nutrient data, and then also analyzing data in Sentinel-2 and Nmap or potentially emit for that stuff. And then also doing flyovers at Sandy and Brady Lake, which is very nearby, because they also have high concentrations of the invasive submerged aquatic vegetation of Nias minor, to see if we can't generate a model to predict where these guys are located, the invasive species are located. And so those models include using our particular method that was developed here at Kent State that we use in our lab, which is a Faramax rotated principal component analysis to run on these particular sites, and then also uses some machine learning to look at both the algae and the invasive material. And so in summary, Pleasant Hill Lake is a complex system, right? It's got a lot of different inputs, both anthropogenic and geologic, which is why we're seeing this diversity sort of cyanobacteria and diatoms within the lake itself. And so the confirmed presence of severe threats such as the microcystis and other species kind of reinforces this continuous monitoring for public health and safety. And summer research includes from May to October, again, drone, sentinel, using hyperspectral satellite data, ground validation, track these nutrient phytoplankton data, and map invasive SAV. And then our lab currently, looking for additional funding for the summer campaign and welcomes future collaborations. And if you would like to contact me or my advisor, Dr. Ortiz here at Kent, feel free to do so. And so thank you for your time.
Thank you, Michael. Again, if you have any questions for Michael or Isabella, please put them in the chat and we will circle back around to them after our last presenter. So I would like to introduce our next presenter, Shiva Bassinet from Youngstown State University. He's in civil engineering, master's student, researching turbidity, sediment dynamics, and algal bloom development in Tappan Lake using remote sensing and hydrodynamic modeling. Title of his presentation today is Integrated Assessment of Turbidity and Sediment Dynamics in Tappan Lake to detect the role of internal loading for algal blooms using remote sensing, in situ monitoring, and modeling approaches. So I can see your slides, but not in the slideshow format. So if you want to switch over to that format, perfect. Can see it. Thank you.
Good afternoon, everyone. My name is Siva Bosnit, and I'm currently doing my master's in civil and environmental engineering in Youngstown State University. And I'm working on my research titled Integrated Assessment of Turbidity and Sediment Dynamics in Tappan Lake to detect the role of internal loading and algal bloom. And I'll be using remote sensing, some field monitoring, and modeling approaches. Also, this work combined remote sensing, as I said, and field monitoring and modeling approaches for Tappan Lake. And along with that, we're also trying to see in some selected inland lakes in Ohio. Talking about study area, Isabel previously mentioned about Tappan Lake. It's located in Harrison County with an approximate area of 2,350 acres and currently being managed by Muskingum Watershed Conservancy District. Tappan Lake is important because initially it was constructed for flood control, and It's important because it's being served as for water supply to Cadiz village and also for recreational activities. At the same time, the lake has been experiencing concerns relating to algal bloom and turbidity. This makes the lake like a perfect site for research. In this slide, we can see the current condition of the lake, where we can see those green pigments referring to algal bloom. Okay, talking about my research motivation. When I started doing research, what I found is that Tappan Lake has had limited inlet sources. Although it has those limited inlet sources for contributing to nutrients inlet to the lake, it has been experiencing algal bloom. So that drives my research question, whether any other thing is causing algal bloom to occur, and the question goes to internal loading. Internal loading is the process in which sediments within the lake bed gets resuspended due to various reasons like wind or water currents or various lake processes, and along with the sediment release, nutrients get released, which makes the environment favorable for algae to grow. And talking about research objective, my first research objective was to analyze water quality variation across lakes in Ohio, and then try to test the spectral indices for how efficiently they can retrieve water quality. And the third one, to compare between the satellite platforms used, how efficient they are, and finally to examine the internal loading in algal bloom formation. We divided the research into two parts. The first one being a surface investigation, where we try to see surface water quality and surface water condition, and then move to the subsurface investigation. But first, talking about surface investigation, for remote sensing analysis, we took two satellite platforms, Sentinel and Landsat. Talking about Sentinel, it is developed by European Space Agency with a spatial resolution of 10 meters and a revisit time of 5 days, which makes taking the data over wide range of dates within 5 days. And I primarily used Sentinel-2 with two satellites, Sentinel-2A and Sentinel-2B, with the same sensors, and the next one is Landsat. And within Landsat, I selected three different satellite sensors from Landsat 8-9, Landsat 7, and Landsat 4-5 to do water quality analysis for a wide range of dates. Sentinel-2 can track image from 2013, and Landsat from 1980s. So a wide range of dates can be used. And Landsat being developed by NASA and USGS with a spatial resolution of 30 meters and a revisit time of 16 days. This slide shows when those satellites were being operated. Okay, to compare the satellite data, basically the indices extracted with water quality, we collected field data during summer of 2024 and summer of 2025. The data collection protocols were we were collecting data bi-weekly, and we had 11 different monitoring stations, and those data were collected using instrument called YSI exosonde, where different parameters were collected, but specific to my research, I used chlorophyll A and turbidity data. Talking about processing those images extracted, I used ArcGIS Pro for that, and use raster calculator for extracting the indices, and for correlating turbidity, I used normalized difference turbidity index, and for chlorophyll, the normalized difference chlorophyll index, and the combinations of some bands and the ratios for testing the total suspended solids. You can see the interface of ArcGIS Pro with those bands and the stations as well. And to evaluate whether the satellite is performing good or not, we compared with field observations, and we used regression analysis correlating with the R-square value, and apart from just from analyzing the correlation, we also compared the efficiency between the satellite platform, whether Sentinel-2 works better or Landsat. Okay, and the next part of research was the subsurface investigation, where we try to see how lake processes are occurring inside of the lake. And for that, the first thing we used was ADCP. It's an instrument called Acoustic Doppler Current Profiler, which helped me extract data on water velocity, and using that data, I was able to determine the bed shear stress and the suspended sediment concentration. In the picture, we can see the ADCP being mounted on the side of the boat to collect the data. And this slide shows the interface of a software called River Surveyor Lib, which was specific to the ADCP that I used. It was an M9 ADCP from Sontec, and this software helped me visualize the depth, the velocity, and other different parameters in real time for on-site monitoring and data quality checks. Okay, and the next thing for subsurface investigation was a hydrodynamic model called EFDC. It's environmental fluid dynamics code, and it helped me to simulate hydrodynamic and sediment transport across the entire lake with me being able to estimate TSS. The ADCP data was done for extracting data across selected transects, but using EFDC, I was able to simulate those measurements throughout the entire lake. Initially, when I started the research, it was like a case study for Tappan Lake, but after we conducted the approach for remote sensing at Tappan Lake. Me with my advisor, we discussed on how to move forward with this, and we tried to expand the research from Tappan Lake to some selected inland lakes in Ohio, which has been experiencing algal bloom, and some lakes are included here. With Buckeye Lake, Mosquito, and Grand Lakes amongst highly affected by algal bloom. And also, while we expanded from Tappan Lake to other lakes, ArcGIS, we shifted from ArcGIS to Google Earth Engine for indices extraction, because Google Earth Engine was able is a cloud-based processing, so it won't take as much time as in ArcGIS Pro for all those downloading of the images for particular dates, and also it makes the processing more efficient and more faster. And this interface shows how Google Earth Engine was used for indices extraction. And key findings from my research was amongst the satellite platforms used, Sentinel performed better in terms of chlorophyll A extraction. And in terms of turbidity, the relation was quite weak, and same goes for total suspended. But amongst the satellite platform, Landsat 8 or Landsat 7, Landsat performed better comparing to Sentinel. This slide is one of the interesting finding from our research, where I used ArcGIS Pro for the Sentinel data for chlorophyll A visualization using a heat map, and I did analyze the total suspended solid from EFDC model, and what I found was that the lower eastern region of the lake had high chlorophyll concentration, and interestingly, the total suspended solid concentration at the same part was also high, which suggests that sediment related algal growth was happening, meaning internal loading it was possible for the algal bloom. And finally, talking about apart from for the technical part, this research has been quite an experience. We collected field data during summer, and also collected data during summer of 25, specific to those ADCP data collection. Collaborated with MWCD officials for collecting those data, and Finally, I'd like to acknowledge Environmental Stewardship Grant and Student Small Grant that helped fund this research, and also would like to thank MWCD for supporting us collect the data. And also, I'd like to thank Orba, Orsanko, and everyone for giving me this opportunity. And thanks everyone for listening.
Thank you, Shiva. Okay, so we have about 5 minutes for questions here. You can feel free to unmute and ask the question yourself, or pop any questions you have into the chat. There's a couple comments here in the chat for Isabella. It looks like she answered that already, but is there other questions from the group here?
I had a quick one. For all the projects, do you all see any potential to work with any citizen science groups on some of these? It seems like there'd be a lot of potential, with the microplastics, and I believe the Muskingum Conservancy District also has a citizen science program for algal monitoring.
Direct that to Isabella, Michael, or Shiva. You have experience, or have you talked with Muskingum Watershed Conservancy about that, or has there been interest in citizen science during your research?
I haven't talked too much with them about that. I worked mainly with Bailey. She works there, but her and I mainly our discussions were about my thesis research. And then when Matt was still part of the Muskingum Watershed Conservancy, I worked with him a little bit last year, but I haven't talked too much to anyone about that yet.
So Bailey actually invited our lab group down to Pleasant Hill Lake. I guess they give some type of talk over the summer. And so we're going to attend that, where there's more of a gathering of folks to talk about the health of the lake and those types of things. So we're working towards that.
Thank
And,
you.
it was similar to me as well. Like Matt and Bailey, they helped me conduct those field data, and it was mostly about that field data collection.
Thank you.
Any other questions? Is there, I know we had two presentations here that focused on harmful algal blooms and one on microplastics, but from each of your perspectives, is there any crossover there? Do microplastics and harmful algal blooms have any sort of connection at all? Or I know it's nutrient driven, but is there any sort of complication or exacerbation of harmful algal blooms from high levels of microplastics in the water?
I don't know if it influences harmful algal blooms, but I know that microplastics can like almost get stuck in them, and it can create they're called flocks, but it makes it easier to transport microplastics throughout the surface water. And also when you're trying to sample for microplastics, it can become a lot harder to identify them and also collect them. Like when I was choosing my plankton net size, we had to really take that into consideration and actually change the net size originally because they will clog the net up, and then it just interferes with the types of transects you're trying to do or the amount that you're trying to collect. I had that happen in Lake Erie this summer, where it's really hard to dissolve too.
So it's
I
more
don't-
the reverse. The harmful algal blooms allow the microplastics to maybe move in areas that they wouldn't have normally been able to
Mhm.
move out into the deeper water.
Yeah, and it's harder to sample for them too. I don't know how they affect them, but that's just what I know about like the relationship there.
Let's see, there was a question here. It says, what about the plastic eating bacteria? Might those be able to help? This question was from Jennifer Wu. You?
Those those probably could help. I don't know much about that. I've read a little bit about it. I'm sure that could help with the concentration that I found, though, to make the concentration smaller.
Okay, well, I would like to thank each of you for presenting here today, and the best of in your future endeavors with completing your research and defending your thesis and moving on to your internships and jobs you have lined up for the summer. Thank you for your time today, and feel free to reach out if you have any questions or concerns or interest in the future for how Orba can support what you're doing. Thank you.
Thank you for the opportunity. Appreciate it.
Thank you.
Yeah, thank you.